Come on guys, let's learn auto scaling and load balancing today. So first let's see what is auto scaling. As the name suggests, auto scaling is a AWS service that automatically adjusts the number of instances or number of resources based on what? Based on the demand. Now consider an e-commerce application which has only one instance to handle the demand. Now for some reasons demand on this particular e-commerce application increases, we should add some more instances for this. So according to the demand, we have added 2 more instances for this. Now after some time, if there is a drop in demand, then we should drop some of the instances. So if you are using auto scaling, this adding and dropping of the instances will be done automatically without any manual intervention. So there are 2 main advantages if you are using auto scaling. One is no downtime, because if there is a spike in demand, then it will add EC2 instances accordingly. Similarly, it will save a lot of cost, because if there is a low demand, it will reduce the number of instances. In turn, it will also reduce the cost. So it will save a lot of money for you. Now let's see 3 main components of auto scaling. So first component is auto scaling groups. So this is collection of EC2 instances. It allows you to automatically scale up or scale down the number of EC2 instances. The second component is launch configuration or launch template. So now consider, for example, you have one instance for your application. And now if demand increases, it should create one more instances, right? But for that new instance, what should be the instance type, or what is the OS, whether it is Ubuntu or CentOS, and what is the network settings, what is the security group? We should have all those details, right? So all these details will be defined in a template. That template we call it as launch template or launch configuration. So third component is scaling policies. These are nothing but rules that determine when and how auto scaling will happen. So scaling policy can be something like this. If the CPU used is greater than 70%, then add one instance. Similarly, if the CPU used is less than 30%, then drop one instance. Now let's see the demo of auto scaling. So I have logged into my AWS account, and for auto scaling, first I have to search for EC2 service. So in search bar, search for EC2. Then first, to create auto scaling, first you have to create a launch template. So search for launch template and click on that. Earlier we used to get a launch configuration option also, now only launch template. So let's create launch template, give a name, auto scaling demo. Then template version is fine. Auto scaling guidance is not required. It is also not required. Then go for application OS image. Click on quick start and we will get the option. Out of this option, I will select Ubuntu now and 24.04 only, and instance type I can choose for t2.micro, that is free tier eligible. So all of these options I have explained in EC2 video, so check out that video for more details. So key pair, for SSH key pair I can choose my key pair that I have created earlier. So subnet, can select any template, any subnet here. So I have to select subnet 1A. And security group also I can select existing or create a new security group. Select one existing security group. Then storage is 8 GB, that is fine. So all of these options are fine. So advanced data is not required. So then click on create launch template. So it will create a template now. Now if I go here, so this created one template now, and all of these details will be available, like storage, networking details, all of these options will be available here. So now we have created launch template, and let's create auto scaling group. So search for auto scaling group and click on that, then create auto scaling group and give a name for that, demo auto scaling. Then select that launch template we have created just now, that is auto scaling demo. Then version default one is fine, and all of these details are fine. Then click on next. Then VPC, I will select the customized VPC that we have created in previous session. So select that, or default VPC also fine. Then availability zones and subnets, I will select the 2 public subnets that I have created in previous session. So these availability zones and subnets, very important because, for example, if 4 instances are created via auto scaling, then 2 instances will be added to this particular availability zone, and other 2 instances will be added in this particular availability zone. So 1A it will add 2 instances, 1B it will add other 2 instances. Like, then click on next. Then load balancer I will explain later. So select no load balancer now and click on next. And this is the scaling policy that I have explained earlier. So desired capacity I will choose as 2. So minimum 2 instances will be available at any point of time. Then maximum desired capacity I will explain. I will give it as 5. So maximum it will add 5 instances. So I can add a target tracking scaling policy, or no policy is also fine. So target tracking policy can be any metric type, like a CPU, network in or network out, and load balancer type also. So metric type I will choose average CPU utilization now, and target can be like 80%. So if it increases more than 80%, then one more instance should be added to this particular auto scaling. Then all of these are fine. Instance maintenance policy or no policy is fine. Then click on next. If you want a notification when instances are added or deleted, then you can have a SNS notification also. There is one more service called SNS. So I will cover that in next session. So for now, I ignore that now. So then click on next. Then you can add tags also. Then next. Then you can review all the options you have selected. Once you reviewed, then click on create scaling group. So it will create a scaling group now. So it will take a couple of minutes to launch instances and other things. But auto scaling group is created now. So once I created a auto scaling group, these are the details I can get, like launch template details and other things. So here, if I go to instance management, it added 2 instances because I selected 2 instances as the desired capacity. So at any time, 2 instances will be there. And based on our policy, scaling policy, it will add or drop any other instances. So if CPU is greater than 80%, then it will add one more instance. So auto scaling policy, I can add any other policy also, like dynamic scaling policy, or predictive scaling policy, or schedule actions. So schedule actions, like every day 12 p.m. It should add one more instance, or it should drop one more instance. Like that, I can add a scheduled action also in my scaling policy. Now, if I go to any one of the instances that is created, I can see all the details that I have mentioned in the launch template. It will be added to this particular instances. Like if I go to instance type, that is t2.micro, that is it is taking from the launch template only. Similarly, the subnet security group and other things like. So I have added a security group as launch wizard 2. So it same security group is attached to this particular instance. So both the instances, same security group, same instance type, it will add. Now, if I delete one instance now, or if I terminate one instance, it should automatically launch on one more instance, because desired capacity is 2. So if I go and terminate this instance, so now we can see in instances, old instance is terminated, and the new instances is creating now. So it is in pending state. So in auto scaling group, now both the instances are in service. This is the new instance that is created now. And also you can see the availability zones here. One is created in 1A and another one is created in 1B. So if 4 instances are there, 2 instances will be created in 1A and 2 instances will be created in 1B. So that is about auto scaling. Now let's see the load balancing part. Now let's see what is load balancer. So as the name suggests, it balances or distributes the incoming traffic into multiple instances or multiple servers. So in load balancer, there is one more important component, that is target group. So target group is nothing but a logical group of targets. So targets can be EC2 instances, containers, or Lambda function. Now there are 3 types of load balancer. One is application load balancer, or ALB. Second one is network load balancer, or NLB. Or third one is gateway load balancer, or GWLB. Let's see each of these. So first one is application load balancer. If you are looking for content and path based routing, then go for application load balancer. So in application load balancer, /images can be routed to the one target group, and /API is points to another target group. Similarly, based on the content like images or text, you can route your traffic to different targets. Then ELB works based on application layer or layer 7 of your OSI model, and it is best suited for HTTP and HTTPS traffic. Second one is network load balancer or NLB. If you are looking for ultra high performance, like if you want to handle million of requests per second with low latency, then you can go for NLB. NLB works based on transport layer or layer 4 of your OSI model. It is best suited for TCP and UDP traffic. So third one is gateway load balancer. So it combines network gateway functions with load balancer. So it works based on network layer or layer 3 of OSI model. Generally, we use this in third-party applications like firewalls or intrusion detection and prevention systems or IDS/IPS. That is a function of gateway, right? So these are the three different types of load balancers. Now let's go for the demo. So for load balancing, search for EC2 service first. So in search bar, I can search for EC2, then I can go for load balancing. So for load balancing, I have to create a target group first. So in target groups, we are going to add EC2 instances. So as a target. So for targets, I've already created two EC2 instances that I've already created, and if I search for first instance, it will give this response. This is first instance like this, and if I search for second instance, it will give the response like this is the second instance. So in both these instances, I have installed the engines, apt installed engines. So you can check out my previous video also to how to know how to install engines. Then once I install the engines, I have just created a index.html in var www.html. So if I search for index.html, you can see the content of that index.html also. You can see this is the first instance. So in the second instance, I've added the line like this is the second instance. So like this, I have created two separate instances now. So now let's create a target group and add these two instances as a targets. So for target groups, you can search for target groups here and click on create target group. And you can target I have added instances, so click select instances, so you can add a lambda function and other things also, but now I will create a EC2 instances as the target. So demo target group or demo TG I will name it as. Then protocol HTTP, I will choose as HTTP 80 port only. Then IP address type is IPv4, and VPC I will select a customized VPC that I created in previous session, and protocol version HTTP 1 is fine. I'll check HTTP, and the path will be slash only because I am checking the content in this path only. So then you can click on next. Then you can add the instances. You can select both of these instances as the targets. So include as printing below, and these two targets are added now. And click on create target group. So this will add these two instances in this my instance to my particular target group. So let's create a load balancer now. Search for load balancer and click on load balancers. Then create load balancer. So in load balancer, we have the three options that I've already explained, like ALB, NLB, and gateway load balancer. I'm going to create a application load balancer because this is HTTP traffic. You can see this is HTTP traffic. So I'm going to select ALB. So click on create, then give a load balancer name. I'll name it as ALB demo, and it will be internet facing, and IPv4 I can select. Then VPC will be training VPC, that is a custom VPC. Then availability zones, I'm going to create select both these two and subnet these public subnets only. Then security group, I will choose launch wizard 2. Default is not required, and then the listener and routing, this I have to set up. So HTTP port 80, then I have to select a target group, that is demo TG that I have created just now. You can add other listeners also, but I'm going to leave like this only, so you can ignore these options for now. Then click on create load balancer. So it will create a load balancer now, and once it is created a load balancer, I will get the load balancer URL also. URL means DNS. So if I select this and if I open this in any browser, I should be able to reach out to any one of the instances. Now I will get this site can't be reached because it is still in a provisioning state. So if I go here, it is still in a provisioning state. You can see status is in provisioning. So now we can see the status is active, and if I go to this particular DNS now, I should be able to access. So you can see this is the second instance. So it reached out to my second instance. Now if I refresh this again, it is go to first instance. So every time it is reaching the different instance now. So whenever there is a new request, it is distributing the traffic to the different instances now. So there are only two instances now. So it is distributing among the two instances. So if there are four instances, then it will distribute the traffic to the four instances. This is how load balancing will work. So that's it about auto scaling and load balancing. So subscribe to the channel and keep watching other videos too. Keep learning.